Which planet revolves around the Sun every 165 years, features 14 moons, got its name from sea nymphs, is buffeted by supersonic winds, and has only been photographed from a close distance by a spacecraft once? There is just one planet that springs to mind. That is Neptune. After Jupiter and Saturn, Neptune is the third largest planet body. Despite the fact that Trison's moon is nearly covered by a liquid ocean, it does not show in most solar systems images and photos. Nearly 33 years have passed since NASA's Voyager 2 probe sailed close enough to Neptune to provide humanity with its first and only close encounter with the planet. Scientists were astounded to view the first true photographs of Neptune, courtesy of the Voyager 2 spacecraft and the Hubble Space Telescope. But what did they observe, and how would it affect you? Neptune is the 8th and farthest planet from the Sun, is a beautiful blue sphere named for the Roman deity of the sea, Neptune. Pluto used to hold this distinction, but the International Astronomical Union stripped Pluto of its classification as a planet. Neptune, which is more than 48 billion kilometers from the Sun, orbits the Sun once every 165 years. Thus, it hasn't completed a full circuit around the Sun since its discovery. Neptune, known as a gas giant, is one of 4 planets outside the asteroid belt that fit into this category, along with Jupiter, Saturn, and Uranus. The diameters of these planets range from 4 to 12 times that of Earth. They have no solid surfaces, but huge atmospheres rich in hydrogen and helium, as well as traces of other gases. With an equatorial diameter of over 49,527 kilometers, Neptune is the smallest gas giant in our solar system. Not to mention the fact that it has a volume of nearly 60 Earths. Neptune is the only big planet where a telescope is required to see 1/5 as brilliant as the faintest stars accessible to the naked eye. It has a visible magnitude of 7.8. As a result, it is safe to infer that Neptune was never spotted before telescopes were invented. Earth-based telescopic views of Neptune in recent years have revealed fascinating signs of dynamic cloud patterns on the distant planet, allowing scientists to estimate the speed of the planet's rotational winds. In this environment, Voyager scientists prepared for the first encounter with Neptune, which would likely be the only close-up view of Neptune that many of us would ever have. In the summer of 1989, NASA's Voyager 2 became the first spacecraft to see Neptune, which was its final planetary destination. Voyager 2 passed about 4,828 kilometers above Neptune's North Pole, its closest approach to any planet since leaving Earth many years ago. As a result, Voyager 2 passed within around 40,233 kilometers of Neptune's largest moon, Triton. As a result of what they discovered 5 hours later, researchers and scientists alike were forced to rethink their understanding of the solar system's other major planets. The most obvious feature in Voyager photographs is the planet's blue color due to the concentration of methane in the atmosphere. Because longer wavelengths of sunlight are more easily absorbed by methane, only hues on the blue end of the spectrum are reflected. Neptune is a dynamic planet, despite receiving only 1/3 the amount of sunshine as Jupiter. Jupiter's hurricane-like storms can be seen as a series of large dark patches across the planet's surface. The greatest of these areas is huge enough to hold the entire Earth. The storm was projected to be 8,000 by 4,100 kilometers in size, equivalent to Jupiter's red spot. Initially, it was thought to be a vortex. The Voyager 2 spacecraft photographed Neptune's huge anticyclonic storm in 1989. The feature, dubbed the Great Dark Spot by its discoverers, appears to be an anticyclone similar to Jupiter's Great Red Spot. Neptune's large dark spot is the same size as Jupiter's Great Red Spot and is located at the same latitude. When compared to its relative Jupiter, Neptune's huge black spot is substantially more variable in size and shape. The bright, crisp, cirrus-type clouds that surround the southern and northeastern margins of the enormous dark blotches may be similar to the lenticular clouds that cover Earth's mountains. A dazzling, irregularly shaped eastward-moving cloud orbits Neptune at about 42 degrees south, moving faster than the big dark scooting around Neptune in about 16 hours. This scooter could be a cloud plume rising between cloud decks. Scientists from the Voyager spacecraft have classified a second location, known as D2, 55 degrees south of the enormous black spot. The heat radiated by Neptune's atmosphere was also measured by Voyager above the clouds. At the equator, the atmosphere is hotter, cooler in the middle latitude, and warm again near the South Pole. It's also worth noting that the polarity of Neptune's magnetic fields is identical to that of Jupiter and Saturn, but opposite that of Earth. Furthermore, Neptune's magnetic field sheds light on the planet's structure and dynamics. The Voyager discovered auroras in Neptune's atmosphere that are identical to the northern and southern lights on Earth. Auroras are caused by electromagnetic radiation emitted by the Earth's magnetic field lines. Because of Neptune's complicated magnetic field, auroras can occur over broad portions of the planet rather than just near its magnetic poles. The auroral output on Neptune is expected to be roughly 50 million watts compared to 100 billion watts on Earth. Unlike the other frozen satellites, Voyager has discovered that the Triton's size distinguishes it from the rest. Triton's orbit around Neptune takes 5.87 days and travels at an average distance of 329,915 kilometers above the planet's cloud tops. Triton is around 3/4 the size of Earth's moon and travels in a tilted circular retrograde orbit. Images from Voyager 2 show active geyser-like eruptions that fire out nitrogen gas and dark dust particles many kilometers into space, demonstrating Triton's rich geological history. Triton is approximately 2,703 kilometers across and has a diameter of 2.066 grams per cubic centimeter. This shows that the inside of Triton is more rock-rich than the interiors of Saturn's and Uranus's ice satellites. Triton's high density and retrograde orbit both indicate that it was captured rather than produced in the neighborhood of Neptune. Tidal heating could have warmed the Triton in its initial eccentric orbit, and the satellite could have stayed liquid for up to 1 billion years after Neptune captured it. If this is the case, Triton's history remains a mystery, but at -455 degrees Fahrenheit, volcanism is certainly a component of it. Triton is the coldest planet in the solar system, making it difficult to fathom what is going on there. To commence, what is the definition of cold? What does it mean to be soft? And what exactly is the meaning of youth water ice? The majority of the geologically historic eruptions at very low cryogenic temperatures are caused by nitrogen and methane on Triton. Images from Voyager 2 show multiple geyser-like volcanic vents blasting nitrogen gas coated with extremely minute black particles, indicating such eruptions. To reach the surface of Triton, the particles must first be raised to heights of 3 to 8 miles in the air, and then blown downwind. Scientists have long speculated about the existence of incomplete rings or ring arcs around Neptune. Most scientists believed that shepherding satellites would herd ring particles amongst themselves, preventing them from escaping into space or falling into the planet's atmosphere. This idea explains certain unusual phenomena in the rings of Jupiter, Saturn, and Uranus. As Voyager 2 reaches Neptune, its cameras photographed a ringed arc-like pattern. A closer look at the photographs revealed that the rings reach all the way around the planet. Earthbound scientists, however, were unable to discern the whole rings due to improved resolution and computer processing because the rings are so diffuse and the material in them is so fine. It has recently been determined that one Earth-based ring arc observation through the ring area was generated by the transit of a minor satellite. Researchers were able to calculate the number of rings and a provisional name late in their encounter based on the Voyager's finds. Neptune's surface is very different from that of Earth. The surface of the planet is covered in thick clouds, but the inside is filled with dense pressured gases. The majority of the interior is made up of rock and ice. The more researchers and scientists try to uncover Neptune's mystery, the more we are forced to believe that it's impossible to predict what the future holds for Neptune and its satellites. Thanks for watching the video today. If you enjoyed it, please like, share, and hit the notification bell so you don't miss any more videos from the channel.